All right, FM10 2.7. So these questions are just multi-step problems. They've kind of got more than one triangle involved, and you'll have to solve a piece or pieces of one triangle to get the missing pieces for the second triangle that you might ultimately be looking for. So this is the first question I want to do with you. It says calculate the length of CD, so that's this side right here, from here to here, okay, that side, to the nearest tenth of a centimeter. Okay, all right. Well, CD is part of this triangle right here. So if I look at this triangle, what I will notice is that I'm given an angle, awesome, but I don't have any of the sides of the triangle. So I need at least one of these sides. I need to know one of those sides in order to find this one. So this is a perfect example of where you kind of have to back up a little bit and say, okay, how can I find this side length right here? I have to find that one first, right? So I'm given, I think, enough information in this triangle to solve for BD first. So let's solve for BD. That one has to be first. So do you see that you're given an angle, you're given the opposite side, and this represents the hypotenuse of this, let's say, triangle 1? Everyone see that? So I'll redraw the triangle. You don't have to do that, but I've got 47, and I've got 4.2, and I'm going to find this one here is BD. So do you see how I have to solve that first, and then that will give me the piece that I need for the second triangle? Are we okay with that? So, sorry, what? Yeah? Was there a question or a note? Am I seeing everything properly? Okay, so if I do sine, that's opposite and hypotenuse, right? So I want to find the hypotenuse here, so I'm going to go sine 47 degrees equals 4.2 over BD. So that's the one I'm going to find first. Or BD is 4.2 over sine 47. So now I'll get on the calculator. I'll ask my calculator to give me a hand with that. I'll turn that on, clear that. 4.2 divided by sine 47. 5.74. Okay. So I'm going to 5.74. I'm going to keep as many decimal places as I can, really, in this calculation, because I'm not done yet. So I don't want to round too early. If you round too early, then you're going to sacrifice some precision at the very end, okay? So try and keep as many decimal places as you can. I'm going to try and use this whole decimal number in my future calculations if I can. I'm going to leave that on the calculator screen, just like you should, if you can do that. Or write at least maybe 4 decimal places so you're a little bit more precise. Okay. So now I have this length of 5.74 or so. And so I'm going to use that now for this triangle. 5.74 is here. And I've got 26 here. So that means that I can use 26. This is the hypotenuse, and this is the adjacent. Everyone see that? Adjacent and hypotenuse. So which one is adjacent and hypotenuse? Right on. So cosine of 26 degrees equals adjacent side, which is unknown. That's the CD side, over 5.74. Or 5.74 times cos 26 will give me my answer. So here's what I mean by keeping all the decimal places. You see, if you just use this answer, your calculator should have an answer button or function, and that means it just copies the whole decimal place, so you don't have to retype it out. And then you just go times cos 26. So reusing that previous answer is really, really helpful and saves you some time. So now I've got 5.16. Okay, so it says to the nearest tenth, so now I can go ahead and round that to the nearest tenth. So did anybody else get this number, 5.16 or so? Yeah? So 5.2, and the units are centimeters. Okay. Did anyone else get that number? Yes, did you get this number? Did you do that calculation on your calculator there? Anybody else? Yes? No? Mm-hmm. Everyone's just copying down what I'm doing or working on something else? Okay. All right. Yeah, just make sure that we get that same answer. Okay, that's kind of the first one. Let me just see if I can find it here. Yeah, 5.2. Okay. Okay, pretty easy? Manageable? Yeah? Okay. Let's do another one. This question here, I want to teach you just a few new things here. So this question says this: from the top of a 20-meter high building, a surveyor measured the angle of elevation, we know what that is, horizontal up, to the top of another building, and the angle of depression. Now this is a bit of a new one for you, but angle of depression is horizontal down. So the diagram here, you've got a person on top of this building that's 20 meters high. They're looking up at the top of the next building that's taller than them, and they're looking down at the bottom, at the ground. Okay? So the surveyor sketched this plan of her measurements, determined the height of the taller building to the nearest tenth of a meter. So this is a classic question that you will see over and over again. Someone views an angle of elevation, and then views an angle of depression. And so you have, all of a sudden, you have two important triangles to work with here. And if you draw this imaginary horizontal line, that will make both of these triangles right-angled triangles. So, okay, so I have a quick question for you. I want you to look at this situation, and I want to ask you, do you think that that taller building is more than half or more than double the smaller building, or less than double? Like, do you think this building, is this less than half? The height of this building, is it less than half? Okay, so if you look at these angles, you're looking up at the top of the building, you're looking higher than you're looking at the bottom of the building, right? So you have to look higher up. So yeah, even according to this diagram, this building is going to be a little less than half, looks like. Does it make sense that if this building was exactly half, that you would look the same angle up as the same angle down? Does that make sense? If you were exactly half? So this one is a little bit less than half the length. Okay. You just might notice that, and that's a good thing to notice. If you have to look higher, right? You have to look really high, but you don't have to look down very much. This is a pretty short building over here. Okay. All right, determine the taller building's length. All right, so a 20-meter top, okay, angles. All right. Now, the 20 meters high in this building, there's another measurement that can be stated as 20. Where else is 20 meters on this diagram? Yeah?
It's like the, it's like, I don't know how to describe it. It's like the bottom of the smaller triangle, or like the adjacent of the smaller.
Okay, so the smaller triangle is this bottom one with the 15 degrees, good. So, yeah, this, you see this height of this building here would be the same as this height, right? Yeah. So that from the bottom of the tall building to the horizontal kind of point there. So this is also 20. Yeah, yeah, very good. Everybody see that? So we have the smaller right triangle now. Now I have the opposite side length, and I can actually find this length if I want to, which doesn't really help me actually. I want to find this length, right? Because I'm going to use that to solve for this part of the larger triangle. So I have 20, so this is 20 meters right here, tall, 20. I need to find this part. I don't know that, and that's part of the second triangle. So we're going to break this up into two pieces, and they're going to look something like this. The first one is going to be a right triangle, that's 15 here, and this is 20. So I'm going to, from this angle, this is opposite and this is adjacent. So I'm going to find the adjacent. What is OA, SOCA, TOA? All right, so tan of 15, the angle always goes with the trig function there, equals opposite over adjacent, so 20 over adjacent. So cross multiply and divide, I get adjacent equals 20 divided by tan 15. Okay, let's give that a try here. 20 divided by tan 15. 74.64. So So that's going to be meters, of course. Now that tells us how far the buildings are apart as well. You see that? Because this length, right, is the same as the distance between the base of this one and the base of this one. So that's great. So now I have 74.64, and I am going to now be able to work with this larger triangle, and I'll just redraw it here. This is 30. That's this 30 right here. This is 74.64. This is a right angle, and I am going to solve for this part right here. And that's the second piece that I need to find the total height of the building. So let's do that. Now, what trig function should I use here in this case? I heard a tan. Okay, do we agree with tan?
Yes.
Opposite and adjacent? TOA? Nice. So tan of 30 equals opposite over adjacent. So 74.64 times tan of 30 is what I'm looking for here for that unknown part. So let's do that on the calculator. Calculator? Have you ever heard that? I don't know where I started saying that, but calculator. Okay. So 43.1, 43.09, 43.09. So we're looking for the nearest tenth of a meter. So guess what? I now have the second piece here. So I got this, the tall building is 20. That's the height of this building that we know is horizontally straight across. And then this piece is now the 43 one, right? So the height of the building, so tall building is 43 point, well, we can make that 1 now because we just have a tenth plus 20 equals what? 63.1 meters. That looks pretty good to me so far. And that is exactly what the answer says in the book too there. Okay, so that's a classic question. You're going to see lots of those in your assignments and quizzes and tests and whatever you see. That's a classic question. Okay? So any questions about that? Any problems with that you want to ask me right now? No? You guys got this cased? Yeah? All right. All right. I believe it. I believe you got it cased. Okay, so let's go to a little bit more of a higher level question then. This one looks a little confusing, and it sort of is. It's got two triangles, but now we're dealing with 3 dimensions. Okay? So it's good that there's a diagram, because this is a bit of a hard diagram to draw, but let me just walk you through this one very carefully. Okay? So this is our next example. All right. So from the top of a 90-foot observation tower, that's this one right here, so we know that this is 90. It's not on our diagram, but we'll put it there. A fire ranger observes one fire due west of the tower and at an angle of depression of 5 degrees. So here is the angle of depression, 5. Okay, actually I'll redraw this a bit larger out here. Sorry, 90. Now, why do they have this on an angle? Well, to show you the 3 dimensions. Okay, there's the fire. So this is 5 degrees right there. And another fire due south. So this is west here. This is south. So this is going to be a 90-degree angle between these fires, right? Another one due south at an angle of depression of 2 degrees. Okay, so from the horizontal, we're not looking down as far. So is this fire closer or is it farther away, do you think? Closer, farther. Okay, what do we think? Picture yourself on the tower. You have to look down at 5 degrees to this fire, and over here, you have to only look down 2 degrees. So the 2 degrees one, if you don't have to look down as far, you don't, remember, because something right next to you would be like 89 degrees right there. So the larger this angle is, the depression, the closer. So if this is 5 degrees and this is only 2, that one's further away. That make sense? okay? Because you don't have to look down as far. You're looking more into the distance, okay? So this one's actually a little bit further away. Now, do we need to know that right now? No, but that's a good thing to try and piece together. That's a good thing to, well, that's a bad line. What are you laughing at over there? No, okay, that's what I thought. This is 2 degrees, and here's our fire, okay? Okay, we good so far? Now, could you do this could you write this a different way? Well, if you did this, if you did it like this, like 2-dimensional, here's fire 1, here's fire 2, you don't have, like, where's the 90, where's the 90 in there? Like, you're looking straight above the towers, like, how do I factor in the degrees here and the 90? So you kind of have to view this as a bit of a 3-dimensional thing. Okay, there's the tower, you see? You have to kind of put this into a bit of 3 dimensions, so that's why they did it like that. Was there a question or comment? Oh, yeah, no? Okay, so again, you need this degrees there too somehow. Okay, so don't just draw it 2-dimensionally, you kind of got to think about it 3-dimensionally, and that's what they help you to do here. Okay, so what's the actual question? How far apart are the fires to the nearest foot? So I'm looking for this distance right here. I know that because this is west and this is south, that's a 90 degree, which I did there. But I don't know this side length, I don't know this side length, I don't know any angles, I know nothing. Okay? So we got to try and figure something out first. Is there a way, look at this diagram on the right, so is there a way that I can, like, what piece of this situation do you think we can and should find given this information? Try and pull this over. Okay. Okay, so here's A, B, here's C length, here's D length, here's E. I want to find E. What should I try and find if I can?
C and D.
Oh, if I found C and D, I could use Pythagoras' theorem because it's a right triangle, right? I could use Pythagoras. So I don't really need this angle or this angle. If I could find C and D, okay. So C is part of a triangle over here, but I don't really have a lot of information here. I don't know A. I know this is 90. I don't know anything. What can I find from the information that's given?
You know the 5 degrees is that kind of like forms like a right angle, I guess.
Okay, so this is horizontal and this is vertical. So this, you know, is 90 degrees. So if you know, that's perfect. If you know that this is 5 degrees, and this isn't drawn to scale really, but if you know this is 5 degrees, what is A?
85.
A is 85, because these have to add up to 90 here. Exactly. And so what is B? B is 88. Okay? All right, now we're getting somewhere. So do you see I have an angle measure here and I have a side length, so I could find C now? All right? So I hope you're kind of like piecing this together. It's like if you're sitting there right now and you're like, oh, I would never know how to do that. Well, you know, sketch it out, find the right triangles in the situation, and then see what you're given and see what you can find. To just try and find something. Okay? So here I am going to, and I'm going to rewrite this triangle. You don't have to, but sometimes it's a bit easier. So this is 85 degrees, and this is 90, and that's 90 degrees. So I am going to try and find this side, which is the opposite side. I'm given the adjacent. So opposite adjacent, that is that tan again? So tan of 85 equals opposite side, which is, in this case, C over 90. So 90 times tan of 85 is going to give me C. Okay, let's do that one. 90 times tan 85. 1,028. 1,028. Point something, 0.7047. Okay, does that make sense? Does that make sense? The tower's 90 meters. This is over a kilometer. Does that make sense? Is that? Okay, well, if you're only looking down 5 degrees, that's not very low, right? You're looking the horizon straight across, like really at nothing, and then only 5 degrees down, so it's going to be a ways away, right? That's going to be a ways away. So that would seem a little bit on the close side, almost to me. But 1,000 meters away. Okay, so let's say that's pretty accurate for C there. I've got C now. Could I find D? Let's do the same thing with another triangle. So let's do in black. I'll do this triangle over here. So we got 90. I've got D, and I've got this. I know that this is 2. So what's this one? We said 88. There you go. So opposite, adjacent, we're still using tan. So tan 88 equals D over 90. Does that look good? So 90 times tan of 88 should give us D. Let's try that one. 90 times tan of 88. 2,577, is that what you guys got?
Yeah.
2577.26. Okay, so look at that. This is a little bit further away, isn't it? 1,000 versus 2,500, so it's further away. So that's making sense. It's good. So now we've got enough information to solve one more right triangle. And it's a good thing this was due west and due south, because we know this is a 90 degree, right? So Pythagoras, we're going to use Pythagoras. So we're going to go 1028.7 squared plus 2577.3 squared. And again, use your decimal places, 26. I mean, I just don't want to write it down, but you should use all those decimal places. Equals E squared. We've got E as our length there. Okay, so we're going to take the square root of this whole side to get E all by itself. And let's do that on the calculator. Okay, so in number 3 in your assignment here, we're going to find out JM first, and then we're going to find MK second, and that's going to give us the entire length of the bottom side. So opposite of 40 is JM, the adjacent is 5, so this becomes 5 times tan 40. Uh, 4.195. And then over here, I'll do this side here, MK, and that's 20, opposite is MK, adjacent, so that's tan again. Tan of 20 is opposite, which is MK, over 5. Good, so 5 times tan 20 gives us MK. $1.819. 1.81985. So, if I need JK, I'm going to add up JM plus MK. Does that sound about right? So let's add those up now. I got one on my calculator already. Plus 4.19. It's up there. 5498. I'll use a bunch of decimal places. And I have 6.015 to the nearest 10th. 6.0. So JK is JM plus MK. JK is 6.0. And thank you for the units, centimeters. And we'll circle that, our answer there, for A. Okay, how are we feeling about that? Easy? Okay, that's number 3 for you. Which is really the first question, I think, in your assignment, so. All right, let's see, where's your assignment? I'll grab your assignment for you here in a second. Okay, so, what is this, 2.7? Right here. Okay, so 3AD, 4AB, 6, 8, and 13 is your assignment. You go to the ballroom. did you say? Oh, the washroom. Sorry, I thought you said the ballroom. Like you're gonna go to dancing or something? What are all the other hands up for here?
I said it first.
Like half the class is to go to the bathroom or get water or something right now. Are you serious? All right, hurry up, go, go. Yeah, hurry up, go. Don't get lost in the hallway. Don't stop and talk to anybody. Go relieve yourself and come right back. Oh? That's awkward.
That is awkward.
That's right. That's what a trip to the bathroom usually means. Yes.